Hello friends. For this video, we will be making a project consisting of two programs. One is called Knock Knock and the other is called Who's There. It's a program written in Rust that shows us how to transmit information over the network. I'm Derek from TCI, where we love networking. Let's get into this project. As many of you know, I have a history or a background in teaching networking to students of varying ages and skill ranges. And one of the things I use to help teach those courses is a little utility that I made that explains, or at least demonstrates for students, how ephemeral ports work, how network address translation works, and the effects that it has on what a packet looks like when you send and receive it. And the utility that I write is often something that I use in combination with Wireshark so that the students can inspect the packets. So normally I write that program in C. I've rewritten it a bunch of times over the years. And today for this project, we're going to write that utility in Rust. The reason we're going to use Rust is because it's something new to me, and I think it'll be fun to explore a new technology and kind of give me a new way to write that same utility and explain those same concepts to students. So I'm going to jump on my development laptop and we'll just get right into it. Let's go. So the first thing I'm going to do on my laptop is bring up the command line, and then I'm going to CD to my desktop. And the reason that I'm going to be on the desktop is I think it would be an easier place to place this project. So I'm going to do cargo, new, and I'm going to make the Knock Knock program first. So we'll create that package. Now you'll see that that made a folder right here on my desktop next to Wireshark, one of my good friends. Inside of here, there will be a source directory, a Git project, and then the cargo manifest. We can go directly into source and then just open this up, the main RS Hello World project. We'll just bring that directly into Visual Studio Code. You can use any browser you like. I'm going to turn on all these things that it wants me to. There we go. So it doesn't really matter what IDE you use. You could just use Notepad. This is a program that is only about 40 lines long, which means it all fits on a page. And I'm going to delete the hello world, and we'll just make main again. Okay, and so what are we going to be needing to do this program? The way this program is going to work is it is going to look like you're going to type something like this. So you're going to put knock and then an IP address, and then you're going to get a reply or you're not going to get a reply. That is what this program is going to be looking like. And the first thing I'm going to do when I'm writing my program is this parameter right here. That's something I want. So when I'm working on my Rust program, I'm going to tell it that I want to bring in the standard library environment variables. That's what you would pull in if you want to access whatever was typed on the command line. So we'll be doing that first thing. So I'm going to pull those out of, let's see here. I'm going to pull those out of the environment library by accessing that API. So I believe that this is a vec of strings, and we are going to access those by going to this struct. We're going to talk to the args, and then we are going to collect the args into a vec. So Rust for me looks a little different than what I'm used to. This is very different than C, but essentially what this does is the variable args will now contain essentially an array, an expandable array of whatever was typed on the command line. So normally what I do when I'm writing a program that's command line based is I check to see if I have the right number of parameters. And if I don't, I'll print out the usage. So we'll start with that. We'll do an if statement and we'll just check what number of args we've got. And that's the len when we're checking a vec to see what is in it. And I'm going to check if there's two parameters or not. So if there is not, I'm going to print out the usage, which is knock, and then that's x.x.x, where x is an IP address. So if they don't provide me an argument or they provide an incorrect number of arguments, we're just going to exit the program. So that's the beginning of this. We're just going to check how many we got. Now, if we pass that check, I'm going to assume that whatever parameter they gave us is an IP address. I'm not going to do a lot of validation on it, or it might be a host name. And if that's the case, we'll let the operating system do a lookup, and we'll move on from there. So we're going to create a payload that we're going to send over the network. Oops, all right, payload. This will equal, now what we want here is a string that just says knock knock. However, strings and string slices in Rust are a little bit unusual, so what I really want is a byte array here. So that's what I'm sending, is some unsigned bytes that equate to the ASCII characters for knock knock. Everything that we send on the network is just a stream of bytes. So there's no class information, no type information, none of that. That's what the B gets us in this case. So what are we going to target? That's going to be from args, and we're going to pick out parameter 1, and we're going to clone it so that we have ownership of that. args1 is the first parameter, so that equates to this, and args0 equates to this. It's the name of my executable, so if they've renamed my app to something else, that'll be in the first parameter, but I don't care about that. So that's why I'm starting with 1 here. Now we're going to let the port information, I'm going to pick a high port. Now the reason that I'm picking a high port is because if you pick a port that is under 1024 for listening to incoming requests, you're going to need some elevated privileges to do that. If you pick something on the high range, the maximum being 65 or so, 65,000 or so, something on the high range is considered low privilege and not super duper locked down. So I'm more likely to get a successful listening port if I pick something high in the number range, which is what I'm going to do there. And then we're going to create a destination variable. And this is going to be just the host plus the port. Okay. So, and then we're going to print that out just to be sure so that we have some debugging information. So I'm going to type knock knock. And I'm going to put in a string interpolation right there. And what we're going to do is we're going to use args1. So whatever they typed, we're just going to sort of echo that. So all of this so far that we've got is really just simple boilerplate. So now we're going to start the actual network code. So what we'll do first is we're going to pull in from standard net. We're going to need to bring in the UDP socket struct. And we're going to do some string manipulation as well. So we're going to want to bring in the string slice struct so that we can do a little bit of manipulation with the data that we want to send and receive. So first thing first, create a socket. So let socket equal UDP socket. And then what we're going to do is we're going to type bind. And I sure wish that that would not bring up so many examples. I should close that later. And inside of bind, I'm going to put all zeros. And then on the off chance that there's an error, I'm going to print out general failure, unable to open socket. Now, if you're unfamiliar with the expect command, that instantly kills the program and just prints out that error message. So if there's any kind of error, we don't have to handle it right now. We're just going to crash our program, essentially. So we've got that socket, and we bound to all zeros. So let me explain, when we bind to all zeros, what we're doing is we're telling the operating system, you can decide for us. I want to send a packet, here it is, and you're going to decide what's the active interface. So keep in mind, most people just have one interface and it never comes up that you have to do any thinking here. But on a server or a laptop, you know, a laptop might be wireless, it might be wired, maybe there's a docking station and you plug in. So both wireless and wired might be active at the same time. And I don't want to have to think about that as a guy writing the software. So I just bind to 0000 and I let Windows work it out, or I let Linux work it out, or whatever. So that's the purpose of that. So if we get a socket that's created, it's time to send. We just get right to it. So we're going to do a send to. And what this is going to need is the payload So that's the data that I'm sending, and then it needs somewhere to send it, which is the destination. Now there's a million ways this can fail, so we'll also put an expect on that. And let's see here, what should I print out? Let's say network error, unable to send data. And that'll be that. So what we do now is if we review the code that we've written so far, we are sending the string knock knock to a specific IP address, and I targeted a specific port, which is 64400. Now we're going to get a reply from that says who's there, so we need to handle that reply. So we're going to write a function with that name that I will call show reply, and we're going to give it the socket. So we're going to reuse the socket that we had initially sent from. That'll be the same one that we read from. So we'll define show reply as function show reply, takes a parameter that is the socket, that is a UDP socket. And what are we going to do with this reply? So what we're going to do is reuse the socket that we were sending on, and we're going to receive information back on that same exact socket. And in order to receive information, we need a place to put it. So let's begin by setting aside a mutable buffer. And this is going to be a range of bytes. So I'm going to do some unsigned 8s, 1500 of them. And semicolon on that. So let's see how we did there. So what we're doing is we're creating a space of memory to receive information that is sent back to us from the knock knock side. So we're knocking, and then we're going to get a who's there. So to receive the who's there reply, we set this memory aside. And then the other thing that we're going to want to do is decide how long to wait. So are we going to wait for 10 seconds, 5 seconds for this reply to come back? If I don't specify, there'll be some amount of time, but it might take too long. I'm going to pick 2 seconds, which is 2,000 milliseconds. And the reason I'm going to do that is on average on a LAN with switches, you're going to get an answer in under 1 millisecond. So 2,000, guaranteed nobody's home to send you an answer. So we'll start there. In order to do that, I'm going to access the socket struct, and I'm going to tell it to set read timeout. And this wants a duration struct. So to make a duration struct, I'm going to tell it to create one from seconds. And I'm going to give it 2. And then this might fail. So we're going to give it an expect. And we'll just decide what to do if this should fail. Is we'll tell it unable to set timeout. And this duration struct or class, I'm not sure the best way to reference that in Rust, still getting used to their terminology. We have to bring that in, of course. So we'll bring in standard time duration so that we can use that. And then this part right here is essentially the meat of the program. It's what do we do with this information that we receive. So the first thing we're going to do is tell the operating system, I'm going to listen for up to 2 seconds. And if I get something, what do we do with it? There's a couple different possibilities of what might happen when I ask the operating system to wait for data to come to me. And because there's a couple possibilities, what we're going to use is a match structure. So we're going to do match, and then we're going to tell the system time for us to receive from. So what we want to do with receive from is give it our buffer, mutable. So it's allowed to borrow our buffer memory, fill it with bytes, and then we'll get it back at the end. So when we do this, because we're on a match, a couple of different possibilities need to be taken into account. One is if everything is okay and we got some data. So that's one possibility. And the other one is if there's an error. And if there's an error, I don't really need anything in this regard. We'll just quit the program. And if it's okay, we'll read the payload that we got. Helps to spell okay the way that they want it. There you go. So Rust is going to want either me to handle the payload if I receive it, or it's going to want me to handle the error if I get that instead. The way I'm going to handle the error is I'm just going to print out that there was no one that answered. So I'm going to do print line, no answer. And I put this underscore on E for the error value because I'm not going to access the error value and try to print it out. It's a safe bet. No matter what went wrong, there's no answer, so I don't need to continue there. Now let's deal with the OK arm. What shall we do if we get an OK? What we want to do is inspect the payload. So it is just a stream of bytes, which is not terribly useful, so I'm going to try to turn it into a string slice. So let's try that. I'm going to use the string class, and I'm going to use a function called, let's see, it's going to be from UTF-8. UTF-8 is a standard ASCII style byte conversion to a string. So what we'll do is we'll let that borrow our buffer. It'll look in the buffer, read out all the bytes in there, and it'll try to give me back a string slice. So that may or may not work. So we will match either the success or the error there. So again, we're going to have an OK possibility, which we'll take into account, or we'll have an error possibility, and we'll take that into account if we get anything. So these are our two possibilities when we try to convert from strings. So if there's any illegal characters in there, it'll just error out. So let's deal with the error situation first. What should we do? We'll just print line unable to interpret response. And then I'm curious what that might be, so I'll include the error message in the print line so that we can take a look at that later. Now, in the OK situation, we can actually do a deconstruct and capture that string as soon as it's been matched. So if we get that string, all I want to do is print that out. So I'm going to do print line, and we're going to print out what we got and from who we got it. So that's line, and then that's going to be, let's say, I feel like I'm missing something here. Oh yeah, this OK is wrong. I don't care about the first value, but I do want the source. So I'm going to get two things when I match an OK from socket receive. The OK is going to contain the amount of data it got and then the address it got it from. And I don't really care so much about the data part, but I do care about the from part. So I'm going to print that out as part of the OK match. So if we get a success, we've sent data, we get data back, we can unpack the payload, we can convert that payload to a string, then we'll print out what the string was, and then we'll print out who we got it from, and that the program will just end after that. So that's our whole program. Let's try and build it. Sometimes I make stupid mistakes. Let's do a cargo build. And it says here, I did not call show reply. Can't find function show reply. You know what I should do is probably save what I'm typing. That is a classic Derek mistake, is saving your work. All right. So cargo build works. I'm able to send out a packet and I'm looking for a receive. Let's test our program out. Cargo run, and I get the usage response. The reason I got the usage response is because I didn't give it an IP address. So I have to tell it 192.168.1.100. Knock, knock. No answer. So as near as we can tell, our program is working correctly. We're all done with this one. So I'm going to change directory back to my desktop, and then I'm going to, I'll leave this open because it might come in handy, but what I'm going to do now is I'm going to make a new cargo project. So we'll do cargo new, and it'll be who's there. All right, we got that. So let's look on our desktop. There's the who's there package. It's got a cargo manifest and a Git repository and all the usual. So we're going to open up the main. And there's nothing in here. So we're going to clear that. And now we're going to write the who's there program. The who's there program is way easier than the knock knock program. So we'll be done a lot faster. We're going to be using very similar standard library. Expand that. learn to click. Okay. Very similar standard library stuff. So we'll be bringing in the string crate. We'll be bringing in standard UDP. I often forget net. And we're going to do socket address. And then we're going to do standard library net UDP socket. And that should cover me for setting up a listener and just printing out whatever we get. So that'll be, this is the beginning of the who's there part of the project, half of the utility, the who's there half. And it's so much simpler than the last one. So let's just get right into it. We're going to do the socket right away. So we're going to make a new one, UDP socket. We're going to create it through a bind. And last time we did a bind on all zeros, but on this one, we're going to do something a little bit different. Not all zeros. I'm going to include the port this time. And the reason I'm going to include the port, this might fail, is because we want to listen for replies. When we're sending out, we don't really need a port for the source. But when we're listening, we need to open up a port address so that we can receive incoming packets on that port. So that's why that's there. The all zeros is a little bit of a different process when you are listening. When you're listening and you place all zeros, you're going to, let me phrase this correctly, you're going to get a listener on every single interface that the operating system wants to give you. So if you're on wireless, it'll listen on wireless. But if you're on wireless and you're also on wired, it'll listen on both of those interfaces. And if you have 17 Ethernet ports on the back of a giant server, it'll listen on all 17 of them. So that's what the zeros is about. If you know specifically which one you want, you could specify it, but that's not going to be anything that I'm going to be able to figure out. Now, this might fail, so what are we going to do? Unable to open listener. Okay, so we create the socket, and then I'm going to print out a little message here. Waiting for Knox. Help if I put semicolon where it needs to be. Okay, so what we're going to do is we're going to listen forever. This program will never quit, and it will answer anything it gets in the order it got it. So we're going to make that happen by just typing loop and getting some brackets going right there. And then all we're going to do is set aside a buffer. So it is the exact same situation as we did for show reply on the previous program. So we're going to fill a buffer with zeros, and we're going to make 1,500 of them. So we have a zeroed out buffer, and then we're going to also do receive from. So again, we'll do a match because receive from is going to give us a lot of possible answers. And we're going to give it our buffer so that it can fill it with those bytes. And then we're going to decide what to do. So one possibility is the OK. And you would get from the OK a number of bytes read, and then you'll get a source address. And we'll do something with that. And then the alternative is we'll get an error. And we'll need to do something with that error. And what we will do with an error is we'll just print that out. So I'll just say network error. And I'm curious what that error will be, so I'll include it in the printout. And this will not quit my program. Just because there's an error doesn't mean the program quits. It'll just keep listening. So if network conditions fluctuate, the program as we've written it will just continue to listen to the extent that the operating system is able to keep feeding us packets. Okay, so now we need to decide what we want to do if we did get an OK. What we want to do is interpret the payload that we got. So we're going to use the string struct again, and we're going to once again bring in a from UTF-8. And we're going to, oops, too far over. We're going to give it our buffer. So it's going to borrow our buffer, and it's going to fill a matched variable with these bytes if it can match it as a string. Okay, so recall from last time that you may or may not get an answer that is accurate. So sometimes it'll be okay, and other times it'll be an error. So if we get an error converting from string, we're just going to ignore it. So I'm just going to print out a message that there's been a string error. We can include it. So I'll just call it E. So we'll capture that variable E. And if there's an OK, what we'll do is we'll call it payload. And if we got a payload, we'll print that out. And it'll say something from something. And what we'll do here is we'll do print the payload and print the source IP address. And we'll put a semicolon on that. So let's go over what we've written so far. We're looping forever. We're receiving a packet. We're trying to interpret that packet. And if we get a good one, we're going to open the payload up and look at what we got as a payload. Now, as the who's there half of the utility, I need to reply to this. So we'll do that. If we get a good payload, we'll reply back. So let's do that. We'll type in a function called who's there. We'll give it the socket. Let it borrow our socket. I don't want to just give it away. And then we'll give it the source. So we need to define this who's there function. Luckily, it's incredibly simple. So function who's there is going to need a, let's say, it's going to need a socket. And the type of socket is one that we borrowed. So it's a little different than last time. We're borrowing that socket. And then we're going to need a source, which is a socket address. Let's define that function. So what is who's there's job? Who's there's job is just to fire off a fire and forget response back to the source. So we'll do that. Create a payload. It's going to be a literal byte. It's going to say who's there. And then we're going to send it. Send that payload. Then we're going to let it borrow the source address for a second. And we're going to do .expect, because this might fail. Network error, sending reply. Okay. And that is the whole thing for who's there. Let's try and build this, and hopefully I didn't make any incredibly stupid mistakes while I was typing that. So we'll do cargo build under the who's there. Oops. Helps to be in the who's there project directory. Now we can do cargo build. It finished. So let's do cargo run. It says waiting for Knox. I'm going to make a new command line. I'm going to change to my desktop. I'm going to change to the knock directory. And I'm going to say cargo run 127.0.0.1. And I got an answer. Let me check it what I got. Okay, so those are the two pieces of output that I like to show students. I like to show students the ephemeral port, which you see as 54690 in this case. And when I create a bigger network to run this utility on, I like to show them the effects of network address translation. I like to log into the router and show them the contracting table. And then I like to open up Wireshark and I like to intercept the back and forth so that the student can see the entire conversation as it happens. Now that we've built the program, all you have to do is put the exe on a thumb drive and then distribute that to your various testing laptops. One of your laptops will be the listener and your other laptops will be the senders that do the knock-knock. All right, I hope that was interesting and that you learned something. Things that are worth remembering from that exercise is that send to and receive from are blocking. So your program will pause at that line and not complete until it either times out or it gets an error or it gets a successful condition. So just keep in mind, if you're trying to write something more elaborate, that might be a video game or something, you'll want to spawn either a thread or look into creating some sort of async framework and functions. One of the major ones that you'll probably want to start with as soon as you've gotten the taste for sending datagrams is the Tokio library. I'll link to it inside my description. You're going to hear about it everywhere you go. It is the gold standard. So that'll be the next thing you'll want to tackle. This is just a very basic, built-in standard library way to send datagrams. Hope that's been interesting. You're going to see this utility in the very next video I do, where I go over some of the effects of passing data along a multiple router path. Until that video, I will see you again soon. Happy network building, everyone.